We are extremely lucky to have Pete Worden visiting us long distance. He has an extremely busy travel schedule, and so we really appreciate him taking the time to do this. This is probably the biggest development in private space science in history. I don't think that's really hyperbole to say. Breakthrough Starshot project is really incredible, and so I'm sure you'll be as excited as I am to learn more about it. All right, Pete?
Great. I guess you got my just the title up that says Breakthrough Prize, Breakthrough Initiatives.
Yeah.
We can go to the next chart that says prize, and
yeah.
Maybe I can tell you a little bit about how I got involved with the Breakthrough Prize Foundation. About 6 years ago, Vanity Fair came to talk to us at NASA, and I'm sure it wasn't about my fine clothes or wonderful couture. But what they had been enlisted by Yuri Milner to put on a prize ceremony for this big new prize that he had started. He started the Breakthrough Prize in Fundamental Physics, which is a $3 million prize. It's 3 times larger than there's some Swedish prize I heard about. But it's sort of a lower prestige prize, I guess. But since that time, Yuri has got Mark Zuckerberg, Sergey Brin, Andy Whiskey, and Jack Ma have contributed. So there are now 7 major prizes, 5 in life sciences, 1 in math and 1 in physics, plus a number of physics and math early career prizes of $100,000, and then there's a junior breakthrough prize that's about $500,000 prizes for a high school student of video. At any rate, the Vanity Fair had the ceremony at NASA Ames campus. So I got invited as the landlord. It's always good to invite landlords. But if you get the next chart, unlike that Swedish prize, we don't have just some king, we have God doing our prize. So the Morgan Freeman did it last year. But by going to these prize ceremonies, I got to meet Yuri Milner and some of his colleagues. And he started talking to me about a major initiative to actually fund science, not just reward it. But if you get the next chart, these are the breakthrough initiatives. And the primary objective here is to privately fund research that really addresses I think the three key questions of life in the universe. Basically, is there life at all outside the Earth, particularly outside the solar system? Second, is there intelligent life anywhere? And third, can we go there? So we started with our first initiative on July 20th, 15, to go to the next chart. At the Royal Society in London, along with that other guy on there, you can probably see there's Yuri Milner and Stephen Hawking. The purpose of this announcement, if you go to the next chart, was to start Breakthrough Listen, which is a $100 million effort to revitalize our search for extraterrestrial intelligence. Now, I'd say a few years ago, I sort of had the view that, well, we looked, we didn't see anything. But in fact, we haven't really looked very good. So we're mounting a rather sophisticated program. If you go to the next chart, for example, we've at least 20% of the time on the Green Bank radio telescope, which is the largest steered antenna in the world. We also have time on the Park radio telescope. We have optic telescopes to look for laser SETI signals. We've signed an agreement with the Chinese about their new 500-meter telescope, and we signed one last week with Jodrell Bank in the UK, and we're about to sign an agreement with the Meerkat Square Kilometer Array. So we're getting a really good time. We released our first set of we consider higher significance data, and we still think these are noisy data and it's some interference, but we want people to really look at the data. But this was the first major initiative. The next chart is the one that you alluded to, Breakthrough Starshot. 12th of April last year, 2016, in New York at the New World Trade Center Observatory, the One World Observatory. Again, Mr. Milner and Stephen Hawking presided. I will say that both Hawking, Milner, and Mark Zuckerberg are the oversight board for this project. And there's a bunch of the usual suspects there on the side of that picture, including myself. But the main objective was really to see if we can send probes to the nearest star, particularly the Alpha Centauri system. And the breakthroughs that really we made this possible were two key areas. If you go to the next chart, the idea that perhaps we could use directed energy propulsion, where you keep the fuel on the ground and then produce a very, very powerful laser beam. Needless to say, this is not a trivial laser beam. It's about 100 gigawatts of power. It's a square kilometer optical array. This artist's conception kind of isn't very good because we tried to explain to the artists lasers don't look like radio telescopes, but it's a cool picture. But the idea that we now can gang together small lasers to make very, very significant power is a significant breakthrough. We think what we notice that laser power is increasing on a Moore's law, and the decrease of cost is also on a Moore's law. So we believe within a decade or two, it's feasible for something like $10 billion to produce a laser array powerful enough to propel. And if you go to the next chart, a very small spacecraft. We're calling this a nanocraft or a starch. Interestingly enough, when we first looked at this, we thought this was going to be a real challenge to produce really small spacecraft, but in fact, most of these components already exist in that small spacecraft. That's a prototype that was put together by Mason Peck at Cornell. It really looks like a lot of this technology is coming along. And the next chart, of course, this is sort of a bad artist conception again. We would attach this chip to about a 4-meter light sail. The laser then propels it for about 2 minutes. It's a modest 60,000 G acceleration. And at the end of 2 minutes, you're going at a 0.2 C. Needless to say, there's a lot of challenges. Yuri Milner has committed $100 million US over the next 5 years or so to do the basic research. Would follow that for sort of a kind of a $1 billion class prototype, and then hopefully within a couple of decades build the full-scale system. We are certainly aware this may not be the only way to do this, but it seems to be the most promising today. We hope to, by the end of the summer, have RFPs out for some of the key laser and light sail work. So this is moving forward. Now, the next question is there any place to go? So if we go to the next chart, we've started here a couple months ago what we call Breakthrough Watch. And this is, we'd like to see, are there planets, particularly in evidence of life-bearing planets near the star system? If you go to the next chart, you'll see the nearest star system. This is Alpha Centauri. There are 3 stars in the system. And the system is about 4.3 light years away. If you go to the next chart, there's kind of a size comparison of the 3 stars with the sun. Alpha Centauri A and B are more or less solar type, one slightly larger, one slightly smaller than the sun. The age of the system, based on stellar models, is a little older than the sun. And then there's a third distant star, Proxima Centauri, which is a red dwarf star, much smaller than the sun. But this is a very interesting system. But when we made our announcement, we had no idea there was anything interesting there. But if you go to the next chart, sometimes it's better to be located good. In August of last year, the European Southern Observatory had an announcement that they have discovered radial velocity, that there is a terrestrial-sized planet orbiting in the habitable zone of Proxima Centauri. So we now know at least one potentially interesting target. If you go to the next chart, we probably don't need to go there, we already have a picture. But hopefully when we actually fly by, we'll find out that this is an interesting planet. But we are working with major observatories on the ground and also some space systems to fully characterize Proxima b, which is the name of the planet, as well as determine if there are planets around Alpha Centauri A and B. This project is ongoing, and ultimately, hopefully, we'll find evidence of a life-bearing planet, so we have something to look at. Now, the last chart, just want to show that we have an annual conference called the Breakthrough Discuss Conference. We held that in April, and during that conference, we had invited the heads of science of most of the world's space agencies, and most of them showed up, including a few heads of agencies. We are looking at working closely with space agencies around the world and major observatories and science agencies to move our project forward. So far, we've committed a couple $100 million, probably more in the works. We're beginning to think about maybe we'll look for life in our own solar system as well. So a lot of interesting projects, but this represents, to my mind, a really exciting initiative of working with some of the high net worth folks to do really cool science. Well, let me stop there. I'll be happy to answer any questions about any of these projects. So we'll open that up.
I imagine there are a few questions. Yeah.
Hi, Erin Viva, BBC. What kind of science can you do with that tiny nanochip once it arrives at its destination?
Sure. Did you hear that?
Yeah. What the question was? What science we could do with a tiny chip?
Exactly.
Turns out quite a little bit. The basic instrument will be a camera, and by the way, I should mention that we intend to send hundreds to each one of these objects. The challenge is a lot of them will fail in interstellar space. They'll get hit by dust. But certainly cameras of sort of visible and near infrared are very much feasible. That prototype chip has a camera on it. In addition, we're looking at potentially a low or moderate resolution spectrometer. So we could get some spectra. We're also looking is that although we're traveling at point C, we're looking at is there any information we can get from the gas and material that's in the target stellar system. So we are looking at a broad spectrum of things. We're also looking at magnetic field detection. One of the big questions about a planet like Proxima b is awfully close to the primary star there, which is a flare star. Would be a lot of radiation. If the planet has a substantial magnetic field, it could, in some sense, protect itself from radiation. It would be protected. So there's a lot of work yet to do, but we had an initial discussion. Looks like we can put quite a little on a sub-gram chip.
So when you were the director of Ames, you were the biggest supporters of space startups like Made in Space and Planet. To what extent what you're doing now with the Breakthrough Foundation will be supporting these new space entrepreneurs?
I didn't quite get the second part of the question.
He said, how does this support space entrepreneurship, the Breakthrough Initiative?
Well, again, our objective is mostly science. We're a science foundation, so we're certainly, that's the focus. That having been said, I will say that the people I work for are made major investments in space startups. Some of them that aren't so startup anymore, they're pretty big. Mr. Milner, for example, was a major investor in SpaceX and other companies like that. So, one of the things, as we find people with new ideas, I certainly will forward those to our sponsors. I'm not personally involved in developing startups, but it is a pretty cool set of technologies which I think have a lot of promise. I might add that I do have another hat. One thing that the foundation allows me to do, I'm a consultant for the Grand Duchy of Luxembourg, Space Resources, and that's very much focused on finding investments. So if it's related to space resources and developing those, I want to ask to be, that you send me stuff, but I'll be happy to forward that to the right people in Luxembourg.
Are there any other questions?
Once you receive the information from Alpha Centauri and Proxima, how are you going to transmit these captures and this information to the Earth, and how long will it take it to receive this kind of data?
Sure. So, did you hear the question?
Not quite there.
Once you take the images of Proxima Centauri, how will you transmit it back to Earth, and how long will it take?
Well, that's a very good question. On board that chip is a small laser that we would aim back towards the Earth. We would have to use some sort of optical element, either the sail itself or deploy a small, a few tens of centimeter optical element. Lock that on the sun and the position of the Earth, and then the laser is a 1 watt pulse laser. We would then send that signal back, and after we've flown by the target planet. So over the next, number of months, you would transmit via laser a signal back. We then have to use the transmit array on the Earth. The 1 kilometer element is a receiver. That's one of the key things. So it's a 1 kilometer telescope, but we can end up getting, maybe up to 10 kilobytes per second or so. So we'll send the images back over a series of months or whatever other data we've taken. That's one of our big challenges, is making this laser link work over those distances. It certainly works in theory, but we'll probably be doing in the next 5 or 10 years a number of experiments in space to demonstrate that with these chipsats that we can really communicate with via laser.
Sandy.
Hi. I think you just partially answered my question, which is at point 2 of the speed of light, I think it was point 2, it would take 20 years to get to Alpha Centauri, correct?
Mm-hmm.
So what did you imagine doing in that period to track these chips or collect data on the way? What activities are planned for that period, if any?
Well, it's obviously difficult to do a two-way communication with them. We certainly can, from time to time, have them turn on and send a signal to us. That's one of the things we would probably do to get a status report. As I said, we expect to lose a lot. And we're looking at various designs for the sail and the chip. I might say that picture I showed that you sort of suspended the chip from the sail is not the way it would, but we already have done enough designs. We would probably embed multiple components in the sail itself. But at any rate, we certainly hope maybe once a year that we would be able to send a status signal back to the Earth from the chip that they're on their way.
Can the chips collaborate with each other and work as a combination? I mean, do you get combinatorial potential from these chips?
Unfortunately, we can't figure out any way for them to lock onto each other. I mean, these are little tiny things, and they'll be lucky days apart, best, and so that it's the idea that one would communicate with the other, at least with our technology, we can't really figure out how to do that.
Thank you.
Sabi.
So why do you choose one target and only hundreds of spacecraft? The cost of the spacecraft is very low, so you can have a million spacecraft going to everywhere you can imagine.
That's a good question. Yeah, we certainly intend to send spacecraft to, or nanocraft, I guess we'll look to more than Alpha Centauri. Part of our objective is to look at other targets. Of course, Alpha Centauri is particularly appealing, it being only a little over 4 light years away. The next nearest solar type stars are more like 10 or 11 light years away. It's Epsilon Eridani, Tau Ceti, and 61 Cygni A to B. We would undoubtedly send nanochips to those as well. Also, as we're finding red dwarf stars, which are everywhere, seem to have treacherous planets. So, over the next decade or two, we're working with the astronomical community as we find potential targets, Barnard star and the other nearby stars. We would almost assuredly send chips to anything that's in maybe 10 light years. So that looks interesting.
Thank you.
Are you considering nearer term, lower speed solar system science missions as a test?
Yes.
Would you like to name some?
Yeah, just stay tuned.
All right.
That's interesting.
Are you funding any more scholarships for high school or college students?
Well, what we're doing and this is part of the Breakthrough Prize, we have a contest that will be announced in a few months. It'll be the 3rd year of it, that we ask high school students a 5-minute video of some principle of mathematics, physics, or life sciences. Last year we got over 6,000 entries. This year we expect even more. The winner, and last year we picked 2 winners, gets a $250,000 scholarship. The school gets a $125,000 laboratory. Maybe most interesting is the teacher that inspired the student. That's a $50,000 check. I'll tell you, the first year that we gave this out, we called her, and the student hadn't told him he was nominated. And the teacher said, "Are you guys calling from Nigeria or someplace? What's that called? Want my bank account for what?" This last year they were better.
Maybe time for one more question. Space.com.
Also space.com. So essentially, Breakthrough Starshot's like $100 million funding agency. Who are you essentially giving grants to? How do people apply? Is there a list that you provide? And that might also tell us what people are actually doing.
Did you hear the question?
No, not quite. You can repeat it.
So when you do fund this project, who specifically are you funding, and will you publish a list of exactly what the money is going towards?
Yeah, absolutely. What we've done to date is, like with Breakthrough Listen, we've, the initial funding for that was most of it was for the University of California at Berkeley. They are the principal investigator for it. We've written separate track with Green Bank Observatory and Parks. We're in negotiations, as I said, with the Meerkat Square Kilometer. Once those contracts are done, I think we'll have them all put on the website. For Breakthrough Watch, we signed an agreement with the European Southern Observatory for the initial observations of Centauri. We're in discussions with other observatories. We also have begun a spacecraft design effort for a small astrometric mission to watch Alpha Centauri A and B. The PI for that is the University of Sydney, Australia. We're finalizing that contract. We're also working with space agencies. I think we have an agreement for negotiating with the Italian Space Agency, potentially also JAXA. So as we do these things, we'll try it. There'll be press releases and so on. But it's probably, we haven't listed a specific list of who the partners and contractors are, but that's a good idea to do that Starshot, as I mentioned, date, virtually all the funding has gone toward members of our advisory committee. The names of the advisory committee are on the website. About 30 members. Some of them we have paid consulting fees if we're asking them to do more intensive work. So again, as these things come out, we will definitely make sure the objective is to be completely open and really work globally.
All right, I think that's it. Thank you again so much.
Thank you. Sorry.